One of the more advanced modes that Probe for EPMA gives easy access to is thin film analysis. Firstly, it allows you to easily set multiple conditions to fully automate multi-voltage acquisitions. It also provides an easy way of exporting the data pre-formatted to a STRATAGem format. Having exported the data, this can then be processed in third-party software, for example STRATAGem or BadgerFilm or other thin film packages that allow STRATAGem files to be imported. Multi-condition automation is covered in another video. In this video we're going to cover exporting the data, and then we'll show some examples of processing the data in BadgerFilm. In this first example we've got a simple copper-coated bismuth sample. So I have 4 samples which I've analysed at a range of voltages. Now if we look at the first one, we can see that I've acquired copper on 3 of the spectrometers and bismuth on 2 of the spectrometers in order to improve the counting statistics. Fortunately, PFE makes it very easy to analyse elements on multiple spectrometers. If we go to Analytical Analysis Options, we can see under Calculation Options, the first one is Use Aggregated Intensities for Duplicate Elements. So if we select that, OK, and double click that sample again, we can now see that all the 3 spectrometers with copper on have been amalgamated into a single column, and the 2 columns for bismuth have been amalgamated into a single column. Now if you have done multiple elements or multiple spectrometers, you need to aggregate the data to make it easy to export to STRATAGem or BadgerFilm. Now the output is fairly simple. We go to Output, Save STRATAGem BadgerFilm Format, and the first thing we do is we select all the data files that we want to import for the model. So we start with the first sample and we select the different voltages using Control and click. Now you have some output options. As we can see from the data, I've acquired 12 data points on each of the samples at each of the accelerating voltages. So we can output each of those, all of those data points separately. Or you can just output the average K ratio from those 12 samples. So we'll select that. There's also an option to skip all K ratios with very small values, or to set those values to a minimum value. Now the reason for this is that STRATAGem tends to crash if it finds a 0 value, so this is an error trapping mode. You have the option of saying that your standards have a conductive coating or not. So you check this box and then you can select which element your coating is, what the density is and what the thickness is. But my standards were uncoated, so I'll deselect that. You can also say whether your samples have a conductive coating using the same method. But again, my samples were uncoated. You have 2 options for how you model your layered sample. You can have a single layer on a substrate, or you can have replicating multiple layers. Mine's a simple copper on bismuth, so I'll select copper, and the density is 8.96, so I'll leave that as it is, and my substrate is pure bismuth. You also have the option, if your substrate is an oxide, to check the oxide box. Then you just click Output. Once the output file is generated, we can close that box, and we'll now launch BadgerFilm and open the file there. Now the reason we can use BadgerFilm is that it has an Import STRATAGem file button here, so we'll click that. We'll select the file we've just generated, and you'll see that it gives us a 2-layer model. Layer 1 is copper and the substrate is bismuth as we set it in the description. Now at the moment the copper concentration here is white, which means that this is a floatable value, so when it does the modelling it can vary the composition as well as the thickness. But we know our coating is pure copper, so if we right click on that box it'll turn pale blue, and that value is now fixed value. The substrate is automatically defined as fixed, but if you want that to vary you can. And then we just hit Calculate. So it's come up with a layer 1 density of nearly 18 nanometers, and you can see in the plot here that the symbols are our experimental data and then the curves are the fitted data, and you can see the fit is pretty good. And up here in the table, the K-ratio experimental are the ones we've imported, and then the K-ratio in the grey boxes are the ones calculated from the modelling, and it gives you an error value. In this next example, we're going to use a slightly more complicated model. Here again, I've got a copper deposition, but the bismuth metal substrate was allowed to oxidise before the coating was applied. So we have a 2 coating layers on top of a substrate model. So if we check the analysis conditions, this time we have oxygen, copper and bismuth. Again, copper has been acquired on multiple spectrometers, and I've aggregated the values so that they'll be output to a single column. Again, we can go to output, save STRATAGem films, and again select the samples we want to analyse. I'll choose a different one this time. Again, my standards were uncoated and my samples are uncoated. This time I'm going to just leave all 3 elements selected for the coating, but I will put the density of copper in, and then we click output. The file is generated, and again we'll open BadgerFilm. And this time open the file we've just generated. Now we know we've got a 3-layer model, but the definition says 2, but that's easy to change. We just add 3 there, and we've now got our 2 layers on a substrate. Now at the moment there's nothing in the top layer because we've just generated that, but to add copper we just go to the periodic table over here and click copper, and it puts it in and automatically sets it at 100%. And again we'll right click on that to set that value. We now go to layer 2. Now we've got all 3 elements in here. We don't want the copper in there because we're going to set this as a bismuth oxide. So again we go over to the periodic table, select copper, and it now deselects it from the list. Now we want to put this as Bi2O3, so we can either put in the weight percent concentrations or we can put it in as atomic fractions. So for Bi2O3, oxygen is 0.6, bismuth is 0.4, and this time I'll fix these compositions as well. So I'll right click on that, and again it'll be the layer that'll vary. Now this is a bismuth oxide, so this is 8.90 density, and the substrate is fixed at 100%, and I'll just put the density in for this, which is 9.80, purely so that when it outputs the data it's got the correct density. It doesn't change the calculation at all for the substrate. And again we hit calculate. This will take slightly longer because we're modelling a more complicated model. Now this time we've come up with a copper layer of 12.4 nanometers, a bismuth oxide layer of 27.5 nanometers, and here you can say the fit is reasonably good. Now if we did want to allow the concentration to vary as well as the thickness, so for example we weren't sure that it was a sesquioxide bismuth, we can right click on those to make them white and then hit calculate again, and this will take a little bit longer because we've got more variables to model. Here we see the results have been output, and this time you can see that the oxygen and bismuth contents have varied. So it comes out as slightly oxygen richer than a straight Bi2O3. And that's how you do thin film analysis using PFE.